Hey guys, welcome to question MM314 of the Maths Methods Fortify study guide. So, this question says part of the graph of f of x equals x squared log e of x is shown below. So just this bit here. Find the derivative of x cubed log e of x is our first part. So part A. This is a 1 mark question. We're not allowed to use our calculator, so we've got to keep that in mind. So where are we going to start with this? So firstly, I'm going to say let y equal x squared, x cubed log e of x, because we're dealing with this one down here, remember? Cool. And then we're going to say y is equal to, or let, you can say let again, y is equal to u times v, because remember there's a little times in between here. And the only way we're going to be able to find the derivative of this is by using our product rule, right? Because we've got a product here, a function times another function. So where u is equal to x cubed and v is equal to log e of x. Awesome. So from here, we know that due to our product rule, dy dx is equal to v times du dx plus u times dv dx. Now v is log e of x. Du dx is the derivative of x cubed, which is 3x squared, plus u, which is x cubed, times the derivative of v, which is 1 on x. Right, so the derivative of log e of x is 1 on x. So therefore we get 3x squared log e of x plus x cubed over x, which is x squared. Awesome. Now, that's it. So dy dx is equal to that. That's our first and only mark for this question. So that's our final answer, 3x squared log e of x plus x squared. That's it. Let's move on to part B. Now part B is a 3 mark question. And it is a little tricky because we're dealing with integration by recognition here. Okay, so we've got part B, 3 marks. Now, it says, hence find the area of the shaded region in the graph above, so this area here, in the form a log e of b plus c, where a, b, and c are non-zero real constants. Awesome. So, first things first is, in order to find the area under here, we're going to need to anti-derive this little guy here, f of x. But our problem is, normally we can't anti-derive this because we don't know how to do that in methods. We don't learn that. But the key with this is our hence. Okay, so at the start of part B it says hence, which means we're going to need to use this answer to work out this current answer. Okay, so we know that the derivative of this is this, which means that the antiderivative of this is this. Okay, so we're going to need to find the antiderivative of x squared log e of x, which is what we're looking for. We're going to be able to use that to find it. So the antiderivative of 3x squared log e of x plus x squared dx is equal to x cubed log e of x. Right? Because the derivative of this is this, so the antiderivative of this is this. Now, what we're going to do is our goal here is to get x squared log e of x by itself, okay? Because we want to find out what the integral of that is, or the antiderivative. So what we're going to do is we're actually going to split this integral up into 2 separate sections. So we have 3x squared log e of x, and this is the same process for all integration by recognition questions. So this is exactly the same, but all I've done is I've just split up this integral here into 2 different ones, okay? And that's going to allow us to get x squared log e of x by itself. So what do we do from here? We want to get this by itself, so we're going to minus the integral of x squared. So we get integral of 3x squared log e of x dx equals x cubed log e of x minus the integral of x squared dx. Cool. Now, this 3 is a constant. We don't want it there because we don't have a 3 here. So what we're going to do is we're going to bring that constant out the front. So we end up with 3 times this integral of x squared log e of x dx equals x cubed log e of x. Now, the integral of x squared is x cubed over 3, right? So add 1 to the power, divide it. So we get take away x cubed over 3. Now, our only problem here is that we have this 3 here, which we don't want, okay? So we're going to divide both sides by 3, which means we get the integral of x squared log e of x dx is equal to x cubed log e of x over 3 minus x cubed over 9. Now, I know it seems like we kind of went around in a bit of a circle here, but the whole idea is to find the integral of x squared log e of x, right? Which is this, because we want to find the area under this graph, but we can't do that without knowing the integral of this, and the integral of that is x cubed log e of x on 3, take x cubed on 9, okay? So, just taking a step back a little bit, our first mark comes between here, and our second mark, I don't think we've hit our second mark yet, so we'll keep going. So, now what? Well, we know that we want to find the area from 2 to 4 of this function, so now we need to just evaluate this integral from 2 to 4, okay? So, how do we do that? Well, it's actually pretty straightforward. Let's have a look. So, we know that this integral is this, which means that from 2 to 4 of x squared log e of x dx is equal to this x cubed log e of x over 3 minus x cubed over 9 from 2 to 4, right? It'd be exactly the same as if we said the integral of x squared dx is equal to x cubed on 3, and then we said, therefore, from 2 to 4 of x squared dx equals x cubed on 3 from 2 to 4. Exactly the same thing. It's just a bit more weird because we're not used to seeing these sort of layouts. So this is what we're going to evaluate, right? So what we're going to end up with is, I'm just going to go equals down here. So it's still equal to this. I'm just moving it over so we have a bit of space. So now we just follow our normal integration process. So we grab our 4, sub it in, then grab our 2 and sub it in. So we get 4 cubed log e of 4 over 3 minus 4 cubed over 9. So that's our first bit. And then we're going to minus all the 2's. So 2 cubed log e of 2 over 3 minus 2 cubed over 9. Awesome. Now, what we're going to end up with here is 64 on 3 log e of 4 minus 64 on 9 minus 8 on 3 log e of 2 minus 8 on 9. Actually, by the way, this is our second mark up here. Okay, so this step here is our second mark. Awesome. So from here, what do we get? So adding all this stuff together, we get 128 on 3 log e of 2 minus 8 on 3 log e of 2 minus 56 on 9. Okay, so the reason that I've done this bit here, or not even necessarily the reason, just how I've done it, is this 4 is the same as 2 squared, right? And according to one of our log laws, this power can actually come out the front and multiply to the front and leave that base there. So we've gone, this 2 is up here, we've times that out the front to get 128 on 3, and then that 2 is left in here. Okay, so that's how we've done that. The reason I've done that is because of the format that we want our final answer in, and we'll see that as we go along. So this 56 comes from this 64 and this 8, and then the 8 on 3 is just where it is anyway. So now we're going to join these two things together here, which means we get 120 over 3 log e of 2, right? So we're just doing 128 minus 8, which is 120, and then minus 56 on 9. 120 over 3 is 40, so we get 40 log e of 2 minus 56 on 9 units squared. And that's it. So our area is equal to this. This is our final answer. We get our third mark here as well. And we need to make sure that it's in the format that it asked for it in, right? Because it said we needed to do a log e of b plus c, which is what we've done. A is our 40, b is our 2, and c is our negative 56 on 9. So guys, that's it for part B. If you have any questions about it, actually that's it for the whole thing. That's it for 314. If you have any questions, let me know in the comments below. But otherwise, thank you so much for watching, and I'll see you in the next video.